So today, as a part of our lecture series in constant analysis, we are going to solve a problem where a 2-pole 50 Hz 11 kV turbo generator has a ratio of 100 megawatts and power factor 0.85 lagging and moment of inertia is 10,000 kilograms per meter square, and where we have to calculate inertia constant and moment of inertia. So where poles can be represented as P, so P is equal to 2, F frequency is equal to 50 Hz and 11 kV, where we have a power of 100 megawatts and power factor 0.85 and moment of inertia J is equal to 10,000 kilogram meter square. So to calculate M, we have a formula with moment of inertia J 2 by P whole square omega s into 10 power minus 6, where we represent megajoules. So in order to calculate omega s, we have a formula 2 pi into 50. So from here we have to calculate Ns, which is equal to 2F by P. So from here we already know the value of frequency, which is 50 Hz. So 2 into 50 divided by number of poles will give us 50 rotations per second. So with this Ns, we have to calculate omega s, where we can substitute 2 pi into value of Ns will be 50, which will give us 314.16 electrical radians per second. So to calculate M, the value of J is 10,000 into 2 pi, number of poles will give you 2, the whole square into omega s value was 314.16 into 10 power minus 6. So when we calculate the value for M, it will be 3.14 into 10 power minus 6 megajoules per electrical radians. So we have already calculated the moment of inertia, and next we have to determine its inertia constant h. So the formula for h is pi f into m per units. So as we have already know, a per unit value can be calculated with the help of actual value and the base value. So the per unit formula is actual by base. So here the actual value is m in terms of electrical radians and base value is defined as s. So to calculate S, we have to do, it's a ratio of power divided by power factor. So as we already know, the power is 100 and power factor value is 0.85. So when we divide 100 and 0.85, we will get the value of 117.675 megawatts. So now we have to substitute this base value to calculate the per unit value. So M in electrical radians will be 3.14 into 10 power minus 6 divided by the value of base is 117.675. So when we divide these two, we get a value of 0.0267 per units. So now we have calculated M per units. So this M per unit can be used here to calculate the inertia constant. So where we can substitute 3.14 into M is 50 into M per units, which will be 0.026. So when we multiply all these, we get a value of 4.194, which is to be determined. So in this problem, we had a 2-pole 11 kV turbo generator with inertia value of 10,000 kilogram per meter square, and where we have to determine inertia constant and moment of inertia. So the formula of moment of inertia was J into 2 by P whole square into omega s, and the formula for inertia constant is pi f and m per units. So as we all know, to calculate the per unit value, we have to divide the actual value by the base value. So the base value can be calculated with the help of real power and the power factor. So this is the method which we follow in order to calculate the moment of inertia and inertia constant. So the unit we mention it as electrical radians. So when we mention it as degrees, so the electrical radians means for pi we will be substituting And whereas when we calculate in degrees for pi, we will be substituting a value of 180. So with the help of these formulas, we have calculated inertia constant and moment of inertia. Thank you.